packed files. So I'm going to start with this 102 Unpacking. And for this one, I'm using a packed file which I just got from this Practical Malware Analysis textbook. They wrote a bunch of fake malware to work with, and one of them is packed. So you download this thing and put it someplace. I put mine in the downloads folder. You do have to have your antivirus turned off, or it will freak out. A lot of this stuff triggers antivirus engines. So you get this folder called Practical Malware Analysis Labs, and in there you have a binary collection with a bunch of little files that are executable. I unpacked this earlier. I'm going to delete that, so we'll show you how to make it. All right, so first thing we're going to do is look at the strings. And my favorite tool for looking at the strings is bin text, and they don't include it in the Flare VM, which I'm going to say rather more than I expected to. Even the ones I liked in the Flare VM, they took them away, so you have to download it. I think it originally came from McAfee. And so I just put it in my downloads folder. So I should have bin text. Yep, here it is, bin text 303. This is just a really nice little Windows graphical utility to pull the strings out of a file, like we saw before in the properties in Process Explorer. So I can look at the strings in that lab 0102 file. So that was here, binary collection chapter 1, lab0102.exe. So I load it and go, and this just pulls the strings out of the file. So again, I see this message, this program cannot be run in DOS mode. I wonder if there's any way to make the font bigger. I'm kind of afraid there's not. Doesn't even seem to be any options anywhere. Text length, clear. Nope, there isn't even any menu item anywhere. Nope, all right. Anyway, so you see strings here like http://w, suggesting this is the start of a URL, something called mal service. Now, this is one thing about strings. You don't really know what they are. If you see a string saying like shut down, you don't know if it really executes a shutdown command and shuts down the machine, or if that's just a word in some message it prints. But usually you can pretty much guess what these things are. And so one thing that's cool is here you see libraries that's going to load like kernel32.dil and advanced API 32.dil. So those are the libraries it loads. And here you see the specific API calls. Windows API calls are the functions your userland code uses to execute things in libraries. And it happens in the kernel too. And so what you do is they all have this characteristic naming scheme with each words just rammed together, capital letters at the start of each word, and it often ends in an A or an EX or a W to indicate whether it does ASCII or it is an extended version of an old API call from an older version of Windows, or it uses wide words, which are these Microsoft 16-bit Unicode words. Microsoft uses a really old version of Unicode, 16 bits per character. So get process address, virtual protect, virtual allocation, those are all Windows API calls. Here's another fragment of a URL. If you go down, here's something load library, get process address. Here's Internet Open A, suggesting that this program might have some internet communications. And you can see all that just by looking at the strings. All right, but notice that we did not see the URL it was trying to get to here, just fragments of it. And the problem is, of course, this file is packed. So you can find that out with PEID, which I think they did include with this. Yep, PEID is a program that just gets you general information about an executable file. So I can load that file, lab0102, and when I load it, I can see the language it's written in down here, but for this file, I see nothing found. So that means this file does not appear to have been compiled by any normal compiler, which would have labeled it with what type of compiler it was. And the other thing I see is the sections here are UPX0, UPX1, and UPX2. And that is very strange. All Windows portable executable files, which is every executable file in Windows, is supposed to have a .text section with instructions in it, and a .data section, and a .rdata section with data, and a few others like resource and relocation. But the .text one is the one that has the executable code, and this program does not even have a .text section. So something weird has happened here, and you can tell from this name, UPX, this is the signature of the UPX packer, which is a free open source packer, which is what's been used to pack this file. Now, another thing that's kind of fun is to use this PE view tool, which was one of my favorite tools. This one's still in the Flare VM. PE view will give you a nice view of these executable files. Here you get to see the layout of a Windows portable executable file in a nice way. And let me see again if I can make this bigger. I think I can. Font, Lucida, bold, 16. Good. I think that'll be better for the video and perhaps for people looking live on Twitch. So what you see here on the right is just the raw hexadecimal file, a simple hex dump. This stuff here, so there's the raw data. And I should see, yep, I see ASCII versions of it there, so I think I can make my window bigger here. All right. Notice this message you always see. Now, every Windows executable starts with MZ. That is the mark that indicates it's a Windows exe file. Then you have this message, this program cannot be run in DOS mode. And then down here you have the PE header. This is the really old header for executables that dates all the way from MS-DOS. That's the image, the DOS header here, and the MS-DOS stub program. So this is what it would print if you tried to run it on an MS-DOS machine, if you can find one of them. So for all practical purposes, this is a useless appendage. Here's where the real good stuff starts. This is where portable executable files are, which are all modern Windows executables. So there's a PE mark. You can expand it here. There's the signature, PE. And then there's a file header here with information. And then there's an optional header with more information. Down here, like the image base, which tells you where it's going to load. Almost all Windows portable executable files have an image base of 400,000, which means when they load, they will try to load at that location, and they will regard that as their home base from which to calculate, even if it is a virtual address and their actual address in memory is elsewhere. All right, and here's the sections, UPX0, UPX1, and UPX2, and those are the headers describing where those sections are, and here's the sections. There's nothing in that one. This one here is full of just junk. Looks like maybe encrypted data or something, but down here you got mal service and some kind of funny looking URL junk. All right, and down here, UPX2, here you've got some dills to load and so on. And if you expand this one, this is what actually passes for the executable section. And here you have the import directory table. These are the libraries. You need this if your program is going to use libraries, and all Windows programs use libraries, because they have to at least reach the hardware at some point, and so they need to get to the kernel, so they need to use the library. So they almost always need kernel 32. And here's a few other things it has. This one gives you internet functions. This is the advanced API function. So it loads only 4 libraries, which is a very small number of libraries. And you can go to the import address table here and see, you can see the names of the actual functions that it calls. So it calls the internet library, wininet.dil, and it only uses one function called internet open, A for ASCII. This library, it only uses exit. This library, it only uses create service, and it only uses a few up here. What you're seeing here is not the function calls that would make a real program do anything. You're seeing the unpacker. This is a packed program, and in order to unpack it, all it does is allocate space in memory with this virtual alloc, and then unpack the data and fill it in there. And we're going to see that go. All right, so that's what a packed file looks like. All right, and you can also use this CFF Explorer, which is kind of fun to see the same thing, which is included in this Flare VM. If I open Labo 102, you'll see import directory here. Shows you kernel 32 loads 6 functions, advanced API, and these other ones all load 1. And when you click on this, it will show you the function. There's Internet Open A. Here's the 6 things it loaded. And there's other things you can see here too, but that's all we need out of this program right now. So we're seeing how it loads libraries. So now we're going to unpack the file. Now you can download the UPX and install it on any version of Windows, but it's included by default on this Windows version here. So I can just go to where those things are, which is Downloads, and then Practical Malware Analysis, and then another folder called Practical Malware Analysis Labs, and then I go into Binary Collection, and then into Lab, CD, Lab 01. Let's see, I got to do directory, chapter, oh, okay. CD, chapter 1L. All right. And there's the file I like, lab0102.exe. So you unpack it with just a UPX command line command. And that is that one there, UPX, decompress, -O. I'm going to put it in lab 0102 unpacked .exe, and the input is going to be lab 0102.exe. All right, so it unpacks. So it went from 3 kilobytes up to 16 kilobytes. And so it was shrunk down to only 18% of its full size, which is a nice thing for malware. They like to make it small so it downloads fast and isn't caught by defenses. And so here's the unpacked file. So if I do a directory, I now have this unpacked file, which is bigger. And the unpacked file is going to have strings I can read. So if I run bin text again on the unpacked file, now I'm going to see different strings like system time, get module file name, and if I go down to the bottom, I'm going to see an actual URL, which is the fake URL for the command and control center that these guys put in, http malwareanalysisbook.com, which is where this stuff came from. And here's more the Internet Open calls and so on. Here's mal service and so on, because if you run this, it'll create a malicious service and that sort of thing. So now you've got, here's another copy of the URL it connects to. So you can see a lot more in the strings now that it's unpacked. And you can find the entry point for the unpacked file, and we can look at it in PE view. Let's take a look at that. PE view, okay, and open the unpacked file. And now these section headers are normal. Text, R data, and data, those are the names you normally see in a normal executable. And if you go into, all right, and if I look at, say, the import address table, I see a lot more functions now. More libraries and more functions loaded from each library, because this does some real activity now. I think it infects your machine and sends traffic back to that command and control server to indicate it's infected, because I think this is a fake botnet file or something like that. And it creates a mutex, which is a mark in the file system to mark this machine as infected. So if you run it a second time, it will notice that it's already infected and not try to reinfect it, and so on. This does more or less reasonable things now. And you can see it with CFF Explorer too. If you open the unpacked file and take a look at the import directory, you see now instead of just one in these libraries, it loads a lot more. So if you click on this, it'll show you the specific functions it brought in. It's the same kind of information. All these are just different ways of looking at the portable executable file header. All right, and I think there's some flags defined here in strings, and then there's another file you can examine to find the name of the packer. So those packed files are really very interesting. And let me point out how strange this is. If I go into that directory, which is downloads, let's see, I'm going to do it with the graphical environment. This is for the birds. Downloads. and then practical malware analysis, and binary, and chapter 1. All right, now I can get in fact, I can just, so think about what happened here. If I was to zip this file with, say, WinZip or 7-zip, the file would get smaller, but I could not run it. I would have to unzip it and then run it. And for a malware author, that's no good, because then the complete unpacked file like this, of full size, would be visible on the disk, and that would mean that the antivirus engine might catch it, and the analyst might catch the strings. So this packer is really quite a strange object, UPX. It packs the file and makes it smaller on the disk, and then it loads and still runs just the same. So that is really pretty cool, and the way it does it is it takes each section, like the text section and the resource section and the data section, and it zips them separately, and the unpacker unzips them. And that's what we're going to look at next. But I think this is enough for this one, and I'll stop this video and post it up.